Beat 0. A smartphone processor contains 16 billion transistors. A smartphone processor contains 16 billion transistors smaller than a virus, yet the actual silicon costs pennies. If you melted down a $1,000 processor and sold the raw silicon, you'd get maybe 2 cents. So, where does the other 999,998 towers come from? The answer isn't in the material. It's in the infrastructure that makes the material possible. Beat 1. Let's start with what you're actually buying. Let's start with what you're actually buying when you pay $200 for a phone chip. You're not buying silicon. Silicon is the second most abundant element on Earth. You can buy a pound of it for less than $1. What you're buying is precision. Specifically, you're buying the ability to etch features so small that 50,000 of them fit across the width of a human hair. The interesting part is that this precision doesn't come from better tools or smarter engineers. It comes from a factory that cost $20 billion to build. Beat 2. A chip fab is the most expensive machine. A chip fab is the most expensive machine humans have ever built, not a single machine, an entire building full of machines that work together. The building itself costs $5 billion. The equipment inside costs another $15 billion. And here's what matters. That $20 billion factory produces chips for maybe 5 to 7 years before the technology becomes obsolete, and you need a new $20 billion factory. So every chip that comes out of that factory has to pay back a fraction of that $20 billion cost. Beat 3. The math is brutal and simple. The math is brutal and simple. A modern fab produces about 100,000 wafers per year. Each wafer is a circular disk of silicon about the size of a dinner plate. Each wafer contains about 500 chips. That's 50 million chips per year from one factory. If you divide 20 billion by 50 million chips, you get $400 per chip just to pay for the factory. The reason the chip doesn't cost $400 is that the factory runs for 5 years, not 1. But the reason it costs $200 instead of $2 is that the factory cost is real, and it's baked into every single chip. Beat 4. But the factory cost is only half the story. But the factory cost is only half the story. The reason isn't just amortization, it's yield. Yield is the percentage of chips that actually work when they come off the line. For a 3-nanometer chip, yield is around 95%. That means 5% of the chips are defective and get thrown away. So when you buy a $200 chip, you're actually paying for 1.05 chips. The other 5% of the cost goes to the chips that didn't work. The interesting part is that this 5% defect rate is considered excellent. It's the result of decades of engineering to get it that low. Beat 5. The reason the chip costs $0.02 to make but $200 to buy. The reason the chip costs $0.02 to make but $200 to buy isn't about the silicon itself. It's about the factory that makes it. The silicon costs $0.02. The factory costs $20 billion. The factory runs for 5 years. The yield is 95%. The chip has to pay for all of that. But there's another layer that most people don't think about. The research and development that went into designing the chip in the first place. Beat 6. Designing a modern chip costs $500 million. Designing a modern chip costs $500 million. That's not a typo. A team of 500 engineers working for 5 years, plus all the software tools, plus the testing infrastructure, plus the mistakes and the redesigns. When you buy a $200 chip, you're paying for a fraction of that $500 million design cost too. Spread across 50 million chips, that's another $10 per chip, so now we're at £400 per chip just for the factory and the design. The interesting part is that we still haven't talked about the actual manufacturing process. Beat 7. The manufacturing process is where the real cost lives. The manufacturing process is where the real cost lives. A modern chip fab is a clean room, not just clean, 10,000 times cleaner than a hospital operating room. The air is filtered through HEPA filters. The water is purified to 1 part per billion. The workers wear bunny suits that cover every inch of their body. The reason isn't perfectionism, it's physics. During fabrication, engineers etch features smaller than the wavelength of visible light. A single dust particle, smaller than a bacterium, can scatter that light and ruin the entire chip. The interesting part is the economic math. One fab costs $20 billion and produces 50 million chips per year. Contamination ruins entire wafer batches worth millions. So the fab doesn't just clean air, it rebuilds the air 100 times per hour. It maintains positive pressure so dust can't drift in. It costs $1 billion per year just to keep the cleanroom clean. Beat 8. The cleanroom isn't a luxury, it's the entire cost structure. The cleanroom isn't a luxury, it's the entire cost structure. When you divide $1 billion per year by 50 million chips, that's $20 per chip just for air. Add in the water purification, the equipment maintenance, the worker training, the quality control, and you're at 50 per chip before the actual manufacturing even starts. The reason the chip costs $200 isn't because silicon is expensive. It's because keeping silicon pure enough to work with is expensive. It's because the factory that does this is the most complex machine ever built. It's because the precision required is at the edge of what physics allows. Beat 9. Here's where it gets interesting, the actual transistor. Here's where it gets interesting, the actual transistor. A transistor is a switch, it's made of silicon, and it works by controlling the flow of electrons. In a 3-nanometer chip, the transistor is 3 nanometers wide. That's 0.00003 meters. That's smaller than the wavelength of visible light. That's smaller than most viruses. The reason you can make something that small isn't because you have better hands or better eyes. It's because you use light itself to etch the pattern. You shine ultraviolet light through a mask onto the silicon. The light exposes a chemical layer. You wash away the exposed part. What's left is a pattern 3 nanometers wide. The interesting part is that this process is so precise that a single atom out of place can break the transistor. So the fab doesn't just clean the air, it controls the temperature to within 1 degree. It controls the humidity to within 1%. It controls the vibration of the building to within nanometers. All of this costs money. Beat 10. The reason the chip costs $200 is infrastructure, not material. The reason the chip costs $200 is infrastructure, not material. The silicon costs 0.02. The factory costs $20 billion. The design costs $500 million. The clean room costs $1 billion per year. The precision equipment costs $15 billion. The testing and quality control costs hundreds of millions. All of this is spread across 50 million chips per year. When you buy a $200 chip, you're buying a fraction of all of that. The interesting part is that this cost structure is completely invisible to the consumer. You see a chip, you see a price. You don't see the $20 billion factory behind it. You don't see the 500 engineers who spent 5 years designing it. You don't see the clean room that costs $1 billion per year to maintain. But it's all there, baked into the price. Beat 11. The cost structure is also why only 3 companies make chips. The cost structure is also why only 3 companies make chips at the cutting edge: TSMC, Samsung, and Intel. The reason isn't that they're smarter, it's that they're the only companies that can afford to build a $20 billion factory. A startup can't do it, a mid-size company can't do it, even a large company like Qualcomm doesn't do it. They design chips, but they don't manufacture them. They send the design to TSMC and pay them to make it. The interesting part is that this creates a bottleneck. If TSMC has a problem, the entire world's chip supply is affected. If there's a fire in a fab, millions of chips don't get made. This is why chip shortages happen. It's not because chips are hard to design, it's because the infrastructure to make them is so expensive and so concentrated. Beat 12. So when you buy a $200 chip, you're really buying access. And so when you buy a $200 chip, you're really buying access to a $20 billion factory. You're buying the result of 5 years of design work by 500 engineers. You're buying the precision of a machine that can etch features smaller than viruses. You're buying the cleanroom that costs $1 billion per year to maintain. You're buying the yield rate that took decades to perfect. The silicon itself costs 0.02. Everything else costs $199.98. The reason the chip costs $200 isn't because silicon is expensive. It's because the infrastructure to turn silicon into a transistor is the most expensive, most complex, most precise manufacturing process humans have ever created. And that infrastructure has to be paid for by every single chip that comes out of it.